Guys, let's solve problem 3432 Thai from PubInfo. So I recommend that you read Cherinza yourselves and understand what it says. I'm diving to the problem. So if it's Cherinza Uno, we have 5 numbers, for example, and we are going to read the numbers, and out of them, we must print the biggest prime number. And in the second Cherinza, we will have to cut the numbers in all possible ways into 2 pieces, and out of those pieces we must find the biggest prime number. In the third Cherinza, we will cut the number into 3 pieces, all possible 3 pieces, and out of those pieces we will have to find the prime number. So you see that in all the Cherinza I will have to find the prime numbers, and in order to avoid rewriting the same code more than one time, I will create a function for finding the prime number. So let's start with the Cherinza 1. So we will include fstring using namespace std. So first of all, I'm going to introduce my input method. So the input file is thai_in and the output file is thai_out. So ifstream cin thai.in and offstream cout thai.out. Now, first of all, I'm going to create a variable for Cherinza and number n, and I'm going to create a variable for x that I'm going to read inside the loop every time. So first of all, I'm going to read Cherinza, and then I'm going to read the number n. And if it is Cherinza 1, I'm going to create a loop that runs n times, and in the loop I'm going to read the number x and verify if it's a prime number. So let's create our loop for int I is equal to 1 while I is smaller or equal to n I plus plus. Every time in the loop you read your number x, and now you have to verify if your number x is a prime number, and if it is a prime number we have to find out if it's bigger than the maximum. That's why let's create a variable maximum which is 0 at the beginning, and up here I'm going to create a function that determines if the number is prime number. So if it is prime number, I want my function to return true. If it's not prime number, I want my function to return false. That's why I'm going to create a bool function. So the result will be bool, and the name of the function is yesteprim. And as a parameter it will accept some number x. So let's write the content of our function. So if the number x is smaller than 2, if it's 0 or 1, whatever, we know for sure it's not a prime number. So in that case, I will return false. If x is equal to 2 or bigger than 2, then this will not work. Then I will check another thing. I will start from number 2, and I will go until the square root of my x and check if between 2 and square root of x any number is divisible by x. But to use the square root you have to include cmath. And between 2 and the square root of x, if at any point any number is divisible by x, then it's not a prime number, so we will return false. Our function will stop working and it will return false. And if this did not work and this did not return false, it means it's a prime number. So in that case, you simply return true. And now here, after reading the number, I will check if yesteprim x. I will check if the result of this function is true. As a parameter I will pass x, and if it is true and x is bigger than max, then I know that max is equal to x. And finally, when you finish it, you just print the max. So when you submit your code, you'll get 33 points for solving the first Cherinza. And if your function is a Boolean function, and inside of if you want to check if it's true or false, it's okay only to write this way. This also means if the result is true. Now, if Chirinza is 2. If Chirinza is 2, again you will create a loop that runs n times, and in the loop you are going to read your number x. And now we have to cut our x in all possible ways into two pieces. So let's say we have this number. It can be this, we can cut it this way, or this way. So that's why when I cut the number, I will have the right part of the number and I will have the left part of the number. So this part is, so suppose that this is x, so the right part will be, so and let's say that we have number k which is 10, the right part will be x modulo k, and the left part will be x divided by k. So x modulo 10 will be this, and x divided by 10 will be this. And the next time you multiply it by 10, so it will become 100, and the right and left will change. And you will continue doing this until your left number is equal to 0, or until right number is equal to the number itself. So here, let's create variable l and r and k, which will be 10 at the beginning. And actually we don't have to set any value for k now, but for every number I have read, I will reset k to 10. Then while 1, so I'm going to create an infinite loop. So in this loop, the right side will be x modulo k, and the left side will be x divided by k. And if at any point the left number is 0, I will break the loop, because it means that we couldn't cut into two pieces. The right side has the number x and left side doesn't have anything. Or you can do this way. If r is equal to x, again it's the same logic. We will break the loop. Then if it's not broken, I will multiply k by 100, so that the next time it would be 100, 1000, and so on. And now I must verify if r is a prime number. So if r is prime number and r is bigger than max, then max will be equal to r. And again, I must check if left side is a prime number, and at the same time left side is bigger than max, then max will be equal to l. And finally, when you finish your loop, you will print max. So let's send our solution. And we have 66 points. And now let's come to Chirinza 3. In the Chirinza 3, we will cut our number in all possible 3 numbers. So let's say we have this number. So we will have the left side of the number, the middle part, and we will have the left part of the number, the middle part of the number, and the right part of the number. So let's talk about the right side. So we can cut it, for example, this way, right? Or we can cut it that way, whatever. But first I'm going to talk about the right side. I know for sure that there must be left, medium, and right. So I'm sure that left must have at least 1 digit, and middle number must have at least 1 digit, and the right number can be maximum this. So of course, this can be maximum this, but it can be also 5 or even 45. But this is the maximum it can be. That's why I will try to get this part only and check if this is prime number, if this is prime number, and if this is prime number. So how many times you do it? 3 times. And how many digits you have? 5 digits. So you must do it digit minus 2 times. So I want to check, so if else if charin set 3, I need how many digits this number has. So first of all, let's create a for loop, and in the loop I'm going to read my number x. Then what we do, we have to find out how many digits it has. So let's create some variable chief, and it will be equal to the result of function chiffre, and to the function chiffre I will pass my x, and this function will return the number of digits for this number. But we don't have this function in C++, so we have to create it ourselves. Let's go up here, and since it will return the number of digits and its integer value, my function is of type int, and the name of the function is chiffre, and it, as a parameter, it will get some number x. In the function, I will have some counter which is 0 at the beginning, and while my x is bigger than 0, I will delete the last digit of the number and increase the counter by 1. And once I'm done with all digits, I will return the counter. So here, once I know the number of digits, now I'm solving for the right part of the number. So k is equal to 10. I reset k. And for int I is equal to 1, while I is smaller or equal to chief minus doi. So why do I do it chief minus 2 times? I already explained. If you have this, so this, the minimum left this, and the minimum mid is this, and the right side maximum can be this. So this is chiffre minus doi times. So here I will check if x modulo, if este prim x modulo k, if it is a prime number, and if this number is bigger than max, then max will be equal to this number. And then you will multiply 10 by zeche, so that the next time it is 100, 1000, and so on. And once you are done with this, now we have to find out all possible ways for the middle number, which is this. So the minimum the left can be this, and the minimum the right can be this. So the maximum the middle number can be is this. But it's very difficult to get to the middle number when I have this. That's why I will just delete this one. And now I have a new number where I have to check only this. And when you say that the chiffre reduced by 1, that's why you will have to create a for loop that runs chiffre minus 1 times. So what I do is, first I delete the last digit of the number, I reset k, and I reduce chiffre by 1. And here you'll create a loop that runs chiffre minus 1 times. And again here you'll do this. And once you are done with this one, now I have to check for the left one. So if I delete this one, you remember here we had this. This is the minimum the right can be, this is the minimum the middle can be, and the maximum the left can be is this. So if you delete all of them, you can find the combination for all the numbers the left part can be. And you see the chiffre again reduced by 1. That's why here, after this one, again, you will delete the last digit of the number, you will reduce chiffre by 1, and you will reset 10, you will reset k to 10, and you will have to repeat this, but this time you do it chiffre times. So now, once you are done with all of this, you simply print maximum, and that's it. Let's add our solution. Oh, we have problem. So here, okay, so here it must be chief, not chifre, because chifre is the name of the function. I made a mistake, I'm sorry. And here it will be chief. Let's resubmit our code. Again, we have a problem. Chief was not declared. Why? Oh, I see. Oh, we did a big mistake. We must put all these inside of here. So inside of this for loop, yeah, it must be inside of this for loop. So you do all this n times, and after that you print the value of max. That's it, guys. I hope you understood. Have a nice day.